under the data design, we are going to talk about mainly focusing on the ER diagrams and also the logical diagram. I hope this part you have already done in data technologies or database design. But when it comes to software engineering module, we are going to revisit this, which will again very important to understand the main concepts. So we are revisiting what we have discussed. Right. Now, when it comes to data design, especially in database design, we talk about 3 levels. The first one we call conceptual level data model. So that means usually we look at very high level data design. Now, take for example, you are building a house. Now, to build a house, you have to properly plan it. So we make a plan. So similar to that, when you have a data requirement and when you are asked to develop a database system, you need some plan for that. And this is what exactly we do with high-level data model development, right? So this is called conceptual schema. So there are many techniques people use to design databases, but one is very commonly used is called entity relationship model, which means we always look or represent everything as entities and their relationships. That's why we call it entity relationships or ER model. So in this lesson, we are going to briefly look at what ER model is, and then briefly going to discuss how we construct ER model given a database description. And the output of this is called ER diagrams. So there are 3 main things we are going to discuss. That means entities, relationships, attributes. Now let's take for example, so we have students. So what we can type is, let me say, we have students. So student we can represent as entity. People or anything we can represent as an entity. Usually in ER diagram, graphically we represent entities using rectangles. So for example, we can use a rectangle to represent an entity. So student entity. Actually, when you put all the entities together, we call entity types. And we know students take courses. So course is not the entity. Course is not the entity. Graphically, as I told you earlier, I can use a rectangle shaped block to represent course. And we know student takes courses. That's a relationship. So we can say, okay, the student can take, right? Student takes courses. So the relationships we represent using lines connecting each entity to the relationships. So this is graphical representation of student taking courses. Right. Now we discuss about entities and we discuss about the relationship. This is a relationship. Similar to this, the entities can be described using attributes. Whatever the data that you want to keep about students, we can put them as attributes. What are the attributes? For example, I can use name. Student name is an attribute which we can use to describe. Student ID is another attribute. Student address is not the attributes. Usually, graphical representation for attributes are ellipses. So we can use elliptical shapes to represent attributes. Okay. So we can see, for example, in here, we have 3 such attributes. These ellipses will connect to the rectangle, which represent that each entity can be described using various types of attributes. Right. So these are the ideas that we are going to discuss. Right. Let's move to the next one. Now, usually database projects start with collecting data requirements. So, you know, like in software engineering, you might have already done in the beginning. When you want to develop a piece of software, you collect your requirements. Remember, we talk about functional and non-functional requirements. Similar to that, in software development, when you have a database component, we collect data requirements. So this could be done in various levels. So this small description is about a particular company. And this is about the data requirement. So usually when we want to start modeling conceptual model, we start with a data requirement, data description, something like this. So data description, using this, we should identify what are the entities here, right? Then we need to identify what are the attributes. We need to identify what are the relationships. So that's exactly what we are going to do, right? And by identifying this, we should be able to develop something like this. And this is exactly what I want to discuss in today's one. Right. Having said that, we have company. I told you this description is company, and it says things like, okay, the company is organized into departments. Each department has a unique name, a unique number, and an employee who manages the department. We keep track of the start date of the department manager. A department may have several locations. So you can see this whole description is about particular department. So we can take this as an entity. So department is an entity here. Let's look at the second description. Each department controls a number of projects. Each project has a unique name, unique number, and is located in a single location. And you can see that by going through this, this is about projects. So here, project is an entity. Okay, good. Let's move to the next one. We store each employee's name, social security number, address, salary, sex, date of birth. Each employee works on one department, but may work on several projects. We keep track of number of hours per week that an employee currently works on each project. We also keep track of the direct supervisor of each employee. So you can see that in this paragraph, we talks about employee. So employee is an entity. Right. Then last one. Each employee may have a number of dependents. For each dependent, we keep their name, sex, date, birth date, and relationship to the employee. So finally, we know this is also entity. So if you read all these paragraphs, you can notice that there are 4 entities here. Right. So what is an entity? So in theory, we can say it's about a particular object or a thing which we want to represent in the database, right? So we have seen employee, department, and project, those are entities. Then attributes, what attributes? Attributes are properties which we use to describe an entity. So in our case, if you look at employee, we can describe in employee using name, social security number, address, sex, and birthday. Now here social security means like it's something like national identity card in Sri Lanka. In US, usually we have, they have, 9-digit number, which unique number given for each, employee, right? So those are the main things that we want to describe. But remember, each entity you can have values. If you take particular employee, you have values for each of these attributes. For example, if you take one particular instance, name could be John Smith. Social security number might be 1, 2, 3, 4, 5, 6, 7, 8, 9. Address, okay, we have some address information. Sex, that means the gender is male, and date of birth is, okay, January 9, 1955. And then each attribute, you have a set of values, which is something like a data type. For example, we know when you say a name, John Smith, a name is a set of characters, right? Always it is string type. And if you take the gender, for example, you have a single character. So likewise, we can talk about a data type too. Right. Now, we are going to talk about different types of attributes. When we say attributes, there are various different types. Now, one is we can have simple attributes. For example, earlier I said, right, we have, let's say, student. So we said, okay, we have a student. And I told you this is an entity. So we can have simple attributes. One example, just we can have ID. It's a simple attribute. Then we can have date of birth. I will say DOB, right? So these are called simple attributes. So we can have ellipse shapes to represent, right, simple attributes. And these are connected to entity like this. But sometimes you have several components, right? For example, let's take name. If you take name, right, sometimes name have several components. Like, for example, we can say, okay, initials and surname, right? You can have surname. So which means if you draw this using graphical representation, the name consists of two parts, right? What are the two parts? You have initials and you have surname. And name is, you connect the name to student. So what this means, when you have several components in the attribute, this becomes composite attribute. So when you talk about entity types, you can find simple attributes, you can find composite attributes. Similar to this, you can take something like address. We know in address, we have a number, we have a street, we have a city, you can have several components. So if an attribute has several components, we call composite attribute. Right. Any questions? Next, sometimes these entities, you have multi-valued attributes. Multi-valued means you can have more than one value. Take, for example, color of a car. Nowadays, you see, you will have more than one color, maybe black and red, right? So you can have multiple colors. Similar to this, for example, if you take mobile number, sometimes we might have more than one mobile number. So for example, here we can say, okay, mobile number, but we have multiple values. So this is called multi-value. So I can say, okay, mobile number. So in this particular case, we use double low vowels, right? We have to use double low vowels. I don't know whether I can draw it properly, right? It should come something like this. Okay, double low vowels. So which indicates that this is multi-valued attribute. So this represents that you can have more than one mobile number. We call multi-valued attributes. Okay, derived attribute. Sometimes some attributes can be derived. Derived means you can calculate values from some other attribute. For example, let's say age. We know if you know the date of birth, then you can calculate age, right? So then this becomes a derived value. So usually you have dash ellipse, which represent that this is derived one. So age is a derived attribute because age can be calculated using date of birth. Right. Last part, sometimes you can have composite multi-valued attribute. What do you mean by composite and multi-value? That means if you take particular attribute, you can have several components. At the same time, you can have multiple of them. For example, if you think about the number of degrees particular student can have, when you say a degree can be obtained by particular college or a university. There'll be a graduation year, the type of a degree, and there will be a field. So since degree consists of several values, we can say that this is composite. But then since you can have multiple values for the degrees, it will be multi-valued attributes. Okay, I think you understood what these different attributes types are. Let's move to the next one. Right. Now, when you take an entity, right, you have to have a unique value. So if a particular entity has a unique value, we call it a key attributes. So in this particular case, our case, we have a student, and student ID, if you take, it's a unique. Therefore, we can name it as a key attribute. So we can use a underline in this, will indicate that this value will be a unique value. So it will be a key attribute. But remember, key, there could be more than one key. For example, think about person national ID card number, driving license number, passport number. They are unique, right? So if you take a person, you can have more than one key attributes. So you can see there'll be multiple underline. At the same time, sometimes, now to make a unique value, you have to combine more than one attribute. So remember that these are like all possible cases. Right. Now let me briefly give you, right, the representation. Already I have discussed some of these. So the first one is simply you can use rectangle box to represent entity. And then you can have double rectangle if it is a weak entity. Then you can use a diamond shaped block to represent relationship. You can use a ellipse to represent attributes. You can use a ellipse with an underline to represent key attribute. You can use double ovals to make multi-valued attributes. When you have more than one component in the attribute, you represent like this, which is a composite attribute. Finally, you can have a dash ellipse, which represent derived attributes. Okay, so I think you are now familiar with entities and attributes. There are two things I want to discuss, right? But let's do a small exercise. First of all, can you take a screenshot of this description, because this is our starting point. I want everybody to take a screenshot of this. Once you do that, just let me know. I hope you got a screenshot of this. Thank you. Right, now let's do a small exercise. I want you to identify entity types and attributes and use ER notation that I have drawn. That means draw the entity type like this and draw the attributes and then connect it. So this is all what I want to do, right? Shall we start doing it? So we have 4 different entity types. So I want you to use all the entity types together with their attributes. Can you start doing this?